Welcome to this class discussing the difference between transactional and analytical business systems. In the introduction to this module, we used this diagram to explain that the purpose of a data warehouse was to be able to present data to end users in such a way that they could derive business intelligence. This is an analytical point of view. And we also said that the data warehouse gets its data from multiple sources. And over the next few exercises, you'll see why these data sources are said to be structured according to a transactional point of view. But first, let us introduce you to a case study that will run throughout the data warehousing section of the module. It's the AdventureWorks case study. This is a set of data provided by Microsoft for training purposes, giving 3 years' worth of sales of bicycles and various biking accessories. The data consists of sales from shops in the USA, plus internet sales the world over. Many tutorials published on the internet or within books use these data sets. This means that if you find examples published elsewhere, you can almost certainly translate them into this module. So let's start by looking at 3 typical questions that a customer might ask when they come into a bicycle shop. They could ask if we have a particular bicycle in stock, for example a Raleigh BW2000 in red. The shop assistant is likely to use the transactional computer system to be able to find the answer. They will type in the product number and find out the quantity in stock. If the product is not in stock, then the transactional system is likely to be able to look up the precise date when we expect new stock to arrive into the store. An important feature of the transactional system is that the stock in hand and the date of new stock arrival must be accurate, otherwise the customer is going to be quite annoyed. And the customer might ask for accessories, such as the price of a rain cover that will fold exactly over the bicycle. And this indicates that the database needs to have some sort of relationship between products and subparts, and this at very detailed product-by-product level. The customer is likely to ask more questions. For example, they may wish to order the bicycle by providing their name and address and ask to be contacted when their order is ready. This implies that the transactional system has a facility for entering data as well as reading it. And finally, the customer announces that they have a loyalty discount card, and that's going to affect the price of the whole sale. This means that the shop's transaction support system is going to have to be able to do lookups, such as find out the percentage discount, and then do basic mathematics, such as calculate prices and discounts. All of these requirements means that each shop's system is going to be slightly different, so there will be a different point of sale system in a bicycle sales shop compared to, for example, a bank. Transactional systems are very specific to their shop's users' needs. But before we go on to look at those needs, we want you to write out on paper or typing into a computer 3 more typical questions from customers. You will need these additional questions to check your understanding later in this class. So please pause the video now, and when you are ready, resume to continue the lesson. Here is a summary of the 5 questions that we thought customers might ask. Of course, you should have added 3 of your own. We're going to look at the properties of these questions. First, notice that all 5 questions require the IT system to access very specific records in the shop's database. For example, if a shop sells 10,000 different product lines, then looking up a Raleigh BW2000 in red requires visiting just one of 10,000 records. It's almost like a needle in a haystack. This is going to require the data structures to be very specifically organized to allow specific record access. Secondly, notice that question number 4, where the customer places an order for a bicycle, updates the database. Transactional databases are very often read-write and not just read. The third property to notice is the speed of response. Customers expect quick answers. It's not just customers. If the salespeople in the shop had to wait considerable time to get answers, then their operational efficiency would be detracted too. Now think about the requirement for accuracy of the data. Almost certainly you'll agree that when a price is quoted, it must be accurate to the penny. Or if you're ordering items, it must record the number that you've ordered absolutely precisely. And a fifth very common property of sales systems is that the same question, possibly using different data, is going to be asked many, many times a day. In a bicycle sales shop, you may be happy if you sell 100 different bicycles a day. In a supermarket, it could be 100,000 items per day. Given this high frequency, the system will be set up with functions and menu options that allow quick data capture and quick data calculation. Now let's switch point of view and start asking questions that typical top-level boardroom management might be asking. Let's start with these two questions. Which of our product lines are the most profitable? That is, generate the most income, not necessarily the ones that sell most volume. And secondly, which of our products are growing or declining in sales profit? In order to answer these two questions, firstly, the analytical system needs to be able to calculate profit, and that means drawing on all the sales income and drawing on all the sales costs and then doing the calculation. And secondly, to be able to find out which products are growing or declining in sales profit, the system is going to need to store historic as well as new data. Look at the format of the output too. It may be convenient for us to give the senior management data in the form of tables, but they are much more likely to appreciate it if we can give them graphs, because this allows the business analysts to look at trends and compare trends between different sorts of products. Output formats may not just be standard graphs. It's very common for managers to want to know the density or the proportion of sales within an area. For example, are we already selling to a large proportion of the population, even if that country doesn't actually have all that many people living in it? In other words, is the market saturated? And these market-oriented questions very often lead on to asking about the characteristics or the demographics of the sales base, to be able to find out what characteristics our best customers have, or to be able to find out what our competitors are doing and how their sales compare with ours. We've summarized our 5 questions, and we list key properties. Firstly, nearly every business analytical question requires historic as well as new data. The results are often expressed in comparison with other data, and those are going to need to be supplied and joined in with the data sets. Answers can often require huge processing. For example, all sales when we're working out what percentage of sales is to one target against another. But very often the answers themselves are relatively short and very often graphical. Typically a one-page or one-screen answer is going to be sufficient. Accuracy is a contentious issue. Of course, we should give accurate data if we can, but if it comes to it, sometimes it's better to give estimate data rather than nothing, provided it allows the managers to make some sort of reasonable decision. Once it's clear which product is the best, then it's unlikely that the managers are going to ask the same question again soon. However, having discovered which product is best, they are quite likely to start drilling into the data to try to find out the characteristics. So very often one question triggers a second, third and fourth in the sequence. And finally, a key point. If necessary, managers can wait for their answers. It's not absolutely essential to give sub-second response times for all queries, but using some of the technologies we'll show during the module, interactivity and quick response times very often is quite achievable. We want you to pause the video again and write out on paper or back into your computer document 3 typical business analytical questions you might expect from senior managers about sales of bicycles from the AdventureWorks company. When you are ready, resume the video play. We have listed here a summary of the transactional versus analytical systems properties. On the left, we show the transactional systems. Very frequent queries, very small questions requiring almost instant answers. The system needs to be very available, otherwise the business cannot sell things. Data must be up to date, and accuracy to the penny is essential. Compare that to what the managers need at the top level of the company. Each day there may only be a few uses of the system. Each use, though, could well be massive processing. The answers are likely to be visual, they are likely to be graphical, but they're also likely to be small. Ideally, we want to have the system that's interactive, so people can drill in and explore data. A key factor is that the system must hold historic data as well as new to enable trends to be found. And best available answers are acceptable. As you've seen, these two sets of properties are very different. They are so different as to merit an entirely different approach to the database design. We now want you to look back at your 3 transactional and analytical questions, and to judge how well they match against the properties we have listed. Look through your transactional questions against the left-hand panel, and your analytical questions against the right-hand panel. Pause the video to give yourself good time to consider your answers. When you are ready, resume the video play. OK, in the introduction to this module, we said that analytical systems are very different in nature to transactional systems, and the aim of this video has been to help you to see why. They use different storage techniques, different query techniques, and different management techniques. But that comes later. Let's wrap up this class by looking again at Bill Inman's view of what a data warehouse or an analytical system is. You may remember he said that a data warehouse is a subject-oriented, non-volatile, integrated, time-variant collection of data in support of management's decision-making. In the practical class that follows, you are going to use a data warehouse that is subject-oriented in that it looks at the profits from bicycle sales for AdventureWorks. It has accumulated, but never deleted, data over a 3-year period, allowing us to see trends. It is integrated because it draws all sales and all cost data into a single resource. And it is time variant in that you can get answers using definitions as they applied at the time the data was collected.